Hello, and welcome to 5-Minute Math. Today we are looking at the 6th grade concept of expressions, specifically how we can model equivalent expressions, and we'll do it in 5 minutes or less. So we have some triangles and some circles. Some are empty, some are filled in, and we need to figure out how we can model an equivalent or an equal expression. And you kind of see that word equal within the word equivalent. Well, right now I've just got really just a mess of these circles and triangles. They're not in any type of order. I do see this key over here. So when we have a model like this, you're going to see a key, and you notice that the open circle is a positive 1. The open triangle is positive x. But if it's closed or if it's filled in, it's a negative 1 or a negative x. So that's going to be our key. What I want to do is I want to reorder these. Let me put my circles. So I've got 1, 2, 3 open circles. This is what I want to do. I want to reorder them so that they're nice and neat. Then I've got 2 closed or filled in circles. Got these 2 right here. So I'm going to put them next to each other like this. Then I'll do the same thing with my triangles. I've got 1, 2, 3 empty or open triangles, however you want to say that. 1, 2, 3, and then I've got 2 closed ones, or 2 filled in ones. Let's fill those in. All right, so this is the same thing here. I just made it a little bit more organized because what we're going to be able to see here, it's going to be pretty obvious how we can simplify this expression and generate an equivalent expression because that's what we're looking for. So these 3 open or empty circles, each of these represent 1. So if I think of 1 and 1 and 1, that makes 3. I'll just kind of put the totals down there. And I'll put a little dash so it doesn't look like 10. Now, I've got a negative 1 for each of these closed circles. So minus 1, minus 2. So that's a negative 2. So I can view it as a 3 plus a negative 2, or I can just think of it as a 3 minus 2. Either one, these are 0 pairs. This positive 1 and this negative 1 cancel out. This positive 1 and this negative 1 cancel out. So there's only a positive 1 left, and 3 minus 2 makes 1. So after all those circles, 2 positive cancel out or form a 0 pair with 2 negatives and 2 positives. They make a 0 pair. There's only 1 left. Let's do the same thing for the triangles, and you're going to notice the same thing. I've got an x, an x, and an x. Now, how we do that is we think, what is 1x plus 1x plus 1x? Well, I've got 3 x's. And we're going to keep the x. We don't know what that x represents. We don't need to, but we do need to combine the 3 separate x's into this single term of 3x. That just means I have 3 of these x's, but we're not going to figure out what x is. I've got 2 negative x's. That's what each of those closed triangles mean. So what we have here is we've got a negative 2x. So I can either have 3x plus negative 2x, or I can say 3x minus 2x. They both end up the same thing, and look, we're going to make some 0 pairs, positive x and negative x, positive x and negative x. Remember, a 0 pair is when you get 2 integers that form a 0 when you add them. One's a positive, one's a negative. They are opposite of each other, and they cancel each other out. So I just have a positive x left. So that's all that I have left. I have an x and a 1. So if I wanted to write this with symbols, right, I could either do a 1 plus x. Usually what we do is when we write it, we always put the variable or the unknown first. So I'd probably write this as an x plus 1. Either one works. Now, how can I represent that? Well, I can simply do this. I can represent it with an open or an empty triangle, and an open or an empty circle. That is an equivalent expression because that cancels out, those two cancel out, those two cancel out. All I have left are the open triangle and the open circle.